Welcome to solverfy.
So we have this circuit given over here. This is a 28-volt battery and a resistor of resistance R. 4 ampere current is shown going through this 6 ohm resistance, and this is battery of unknown EMF E. This is just a random point X marked. Here we have a 3 ohm resistance in parallel to this given components, and the current is also given here, which is flowing through this 3 ohm resistance. And we need to find out what will be the current in resistor R. Current in resistor R, what will it be? So for this, what we can observe that this 6 ampere current is coming over here in this direction. 4 ampere is going away from this junction. Let us take this junction J. So this is 4 ampere current, and the current that will be flowing through this resistance of resistor, and this current we will apply Kirchhoff's current law. So at this junction J, total current which is entering, that is 6 ampere, should be equal to total current which is leaving this junction. So 4 ampere plus, let us say this current is I. So 4 plus I. If we solve this, we get the current I as 2 ampere. So in very simple terms, we have found out what will be the current that will be flowing through this resistor of resistance R. So this is 2 ampere. Part B, what we have to identify here is the value of this unknown resistor R. So value of R. To find this, what we can do, we can just apply Kirchhoff's voltage law in any loop. So let us say here we have all the information in this outer loop. So we will apply Kirchhoff's voltage law to this loop. Let us say we name it as A, B, C, D. So what we are considering in loop A, B, C, D, A. In this loop, we apply Kirchhoff's voltage law. And we start from any point. Let us say I start at this point and we take this point as zero potential. Then potential at this point will be decreased by a factor 2 into R by applying Ohm's law. So it will be 0 minus 2 into R, and then the potential at A will be increased by this 28 volt, because we are jumping from negative to the positive side. So plus 28, and that will be the potential at this point. Now again potential at point C will be decreased by 3 into 6. So minus 3 into 6, and that will be the potential at D, because they are connected by a straight wire. And from here we can just solve this equation. So we get minus 2R plus 28 minus 18, and that is 0. So from here we get the value of R as 28 minus 18, that will be 10. So R will be 10 by 2. So we have figured out the value of the unknown resistance R, which is 5 ohm. So let us mention here R as 5 ohm. And the next part, we also need to determine this unknown EMF. So EMF E we need to find. So for this, it is again very clear. We are going to take that loop which has all the information. So here we have the option. Either we can consider this loop or we can consider this loop. So I'll randomly take this loop 1. So in this loop 1, we again apply Kirchhoff's voltage law. So we start at any point. Let's say we start at this point with potential 0. And then in the direction of current, there will be potential decrement. So minus I into R. So 6 into 4 is 24. And then potential at this will be increased by E amount. And that will be the potential here. Again, it will be decreased by 3 into 6. And this will be 0 again. So this again we can solve. Minus 24 minus 18 plus E is equal to 0. And this gives us the value of E as 42 volt. And the last part, here we need to figure out the value of current in R if the given circuit is broken, if the circuit breaks at point X. So if the circuit breaks at this point X, then we need to redraw the circuit. So there will be no use of this part. Let's say this part is Mn. So there will be no use because the circuit is broken. There will be no flow of current. So we will have just these outer components. So let us redraw this. We have 28 volt here. We have a resistor of resistance R and connected to 3 ohm. So here we have figured out the value of R in part 1 as 5 ohm. So here in this case we need to find the current. So current will be total voltage divided by total resistance, that is 5 plus 8. And simplifying this gives us the value of current, that is 28 by 13 amperes. So this is the value of the current which will be flowing through this resistance or through this 3 ohm when circuit is broken at the given point X here.